This is r.d.sharma solution class 12 chapter 19. We are taking exercise 19.26 indefinite integrals. In this exercise, one integral form is introduced and how to solve it, there is a direct formula. We'll try to give you the proof also. If the integration is of the form integration of e raised x and then followed by fx plus f dash x. Now one function is there, call it as say cos x. F dash x will be what? Negative sin x. And if e raised x is in front of that, so this is e raised x cos x minus sin x, so we are calling it as e raised x into fx plus f dash x form. And the direct result of this expression is e raised x fx plus constant of integration. That means if you follow this example, it will be directly e raised x cos x. Fx is cos x, f dash x is negative sin x. So let's see the proof also. Now the proof will be, we'll multiply inside first. That is, the integration will become e raised x into fx, and then we separate this other term also, integration of e raised x into f dash x. Now what we can do is, first let me tell you that integration of ex and differentiation of ex will always be e raised x. It won't change. And if you write fx, the differentiation of fx is simply represented by f dash x. So both the things I explained what all content we have in this expression. Now both the terms you can integrate. You can integrate either the left one, either the right one, or the first one or second one. It will not matter. Alright. So let's start with the first one. We'll keep the second one like that because it is going to cancel. You'll just see in a short while. And you know I late, I told you already, this e is the exponent. So that's why we have to take the fx as the first function. So we are taking fx, e raised x, integration of e raised x, then integration of differentiation of fx, d by dx of fx, and then integration of e raised x, dx, and then dx. And just remove this for now. Integration of e raised x, f dash x is already there. We haven't touched it. Now this first expression will be e raised x because integration of e raised x will be same. D by dx of fx is f dash x inside an integral. E raised x again, integration is e raised x only. Followed by the other term which we haven't touched, e raised x f dash x, and plus constant of integration of course. Now what do you see? The second term and the third term here, they are exactly same, so you can cancel them out. So we are only left with e raised x fx. So initially I told you that this is the final result of this kind of integral, and that is what we have to follow. E raised x cos x minus sin x. Now the formula is e raised x followed by fx plus f dash x. That is, there is a function. We write that function and then we write the differentiation of that function. And we multiply it with e raised x. And the final answer or the result will be e raised x or e to the power x into fx plus constant of integration. So this is what we are going to follow in this question. If we call it as fx, cos x as fx, then what is the f dash x? It will be negative sin x. So we have this exactly same form. Fx plus f dash x, cos x minus sin x is fx plus f dash x. So the integration will become like this. What is the first function? E raised x into fx plus c, that is the final result. So e raised x cos x plus c. Now if this question is worth one number, this is the answer. But if this question is more than 1 marks, that is it may be 2, 3, 5, then you have to change your strategy. You cannot just write the answer and just leave. You have to actually show the proof. So what we will do here is, in this integral e raised x cos x, we are taking it as t. That is, always take e raised x and fx, because this cos x minus sin x is just an example, but it can be fx and f dash x both, anyone of the expression. So now differentiating both the sides, we have taken e raised x into fx, which is cos x equals to t. When we differentiate it, e raised x cos x, and then we have e raised x, and cos x differentiation will be negative sin x. And this will be equal to what? This will be equal to dt by dx because we are differentiating both the sides. Now this e raised x we can take common. When you take common, inside will be cos x minus sin x. When you have this cos x minus sin x and e raised x outside, dx we are taking out from the denominator of the right hand side. So I am taking it here. Now let's integrate it now. When you integrate it, you don't have to integrate the left hand side because this is the question. See, right hand side it will be simply t plus c. But what about this one? This is our integral only. So don't integrate it, just write I I equals to t plus constant of integration. But what was t? Initially t was taken as what? I told you it will be e raised x into fx, which is e raised x into cos x in this case. So e raised x cos x plus constant of integration. So there are two ways. If 1 marks, first level. If more than 1 marks, all you have to describe. So this is how you need to explain it and write it. Now this question, e raised x into 1 by x square minus 2 by x cube. So fx is 1 by x square. If you assume fx equals to 1 by x square, because 1 by x square and 2 by x cube is eminent, and it's quite evident that they are differentiation of one differentiation will give you other. So if you differentiate 1 by x square, it will be negative 2 by x cube, that which I am showing you already. So fx is 1 by x square and f dash x will be negative 2 by x cube. So this integral has become like this: e raised x fx plus f dash x inside the bracket, and this is the formula which you see here also. So the result will be e raised x fx plus constant of integration. That is the formula and the result I told you already. What is fx here? 1 by x square. So e raised x by x square plus constant of integration is your final result. If this question worth 1 marks, it's okay. But if it is not of 1 marks, you cannot just stop here and just write the formula result and get away. You have to prove it. So what we are going to do here is e raised x will keep the first function fx. It can be any, you'll see some questions in the later on part. So 1 by x square is fx. So e raised fx equals to t, we will assume, and then we'll differentiate them. So now I am differentiating both the sides. So 1 by x square differentiation is negative 2 by x cube. 1 by x square will keep like that. E raised x will be e raised x equals to dt by dx. Now I'll just rearrange them and take e raised x outside. So I'm just trying to make it look like the initial question. So e raised x I am taking outside, 1 by x square as first and negative 2 by x cube as the second one. And dx I am bringing it on the left hand side and dt on the right hand side. Now let's integrate both the sides. First we have to differentiate, then we have to integrate. When you integrate, you don't have to integrate the left hand side, because right hand side is simply t plus c. But the left hand side is the original integral we are talking about. This is the integral. So I equals to this t plus c. But t, which initially we assume to be e raised x into 1 by x square. So this integral will become e raised x by x square plus constant of integration. That is the proof of the formula also. So this is how you are going to write, because I always tell you the logic, but the writing is very important. Now this doesn't seem to be following that rule or that scheme, that view, fx plus f dash x into e raised x. But if we just closely look and try to formulate or simplify, you'll see that this will boil down to e raised x into fx plus f dash x. You'll just see. I'm separating these two out, 1 by 1 plus cos x and then plus sin x divided by 1 plus cos x. So 1 by 1 plus cos x plus sin x divided by 1 plus cos x. I've just separated them. Nothing else I have done. Now 1 by 1 plus cos x. E raised x will remain like that. 1 by cos x, I'm just simplifying it. 1 by 1 plus cos x. 1 plus cos x is 2 cos square x by 2. You already know that. Sin x is 2 sin x by 2 cos x by 2. So 2 sin x by 2 cos x by 2, and 1 plus cos x again 2 cos square x by 2. Now this will become 1 by 2 will remain like that, and cos square x by 2 you can take upstairs, and that will be sec square x by 2. And 2 gets cancelled, cos 1 cos gets cancelled, sin x by 2 by cos x by 2 is 10 x by 2. Now e raised x was already there, so now let's go back and do that thing, means multiplying eax and dx. Now if you see this half x sec square x by 2, this seems to be fx. So if you take this half sec square x by 2 and differentiate it, if you call it as fx and differentiate it, you'll get half, you'll get 2 sec x by 2, 10 x by 2, and then sec x by 2 will remain, so sec x by 2, 10 x by 2. That is, it will be 2 sec x by 2, and then again sec x by 2 will be sec x by 2, 10 x by 2, then again 1 by 2 will come. Now this is not going to work out. So that is, I think it's a wrong approach. So we have to take fx as 10x by 2. That I was telling you, that fx and f dash x can be different. It can be swapped in the question. So you have to follow this scheme. Now if you take fx equals to 10x by 2, you see f dash x has already come as half x sec square x by 2. That is why fx is now 10x by 2, which is coming out, which is coming as the second function. We always try to see what we want, but here is the swapping thing. Here tan x by 2 is fx and half sec square x by 2 is f dash x. Alright, the answer is direct, that is e raised x fx plus constant of integration, that is your final answer. Okay, and what is fx? Tan x by 2. You'll not stop here because we have to actually solve it and show it to the examiner that we know the formula and we can do it. So what we'll do is e raised x into fx. If you assume that tan x by 2 is your fx, then e raised fx has to be taken as t, and fx in this case, which I showed you after simplification, that it's tan x by 2. fx is tan x by 2. Now let's differentiate both the sides. So e raised x tan x by 2 is sec square x by 2 into half, plus I'm following the product rule. So tan x by 2, e raised x will remain e raised x equals to t, and you are differentiated, so it will be dt by dx. Now dx will bring on the left hand side upstairs. Let's integrate both the sides now. When we integrate both the sides, the right hand side will be only t plus c. The left hand side we don't need to integrate because when you put that integration sign, it is actually equal to the question. So just write I, because this is the question we need to answer. So I equals to t plus c. What is t? T was assumed to be e raised x tan x by 2 plus constant of integration. This is your answer. So again, if it is of 1 marks, you need to follow the first scheme. If it is more than 1, then you need to show the examiner that how this formula is proved. So what I explain you is here right in front of you. You need to write it exactly or almost similar to this one. E raised x cot x minus cosec square x. Now cot x differentiation is negative cosec square x. So we can see that this function is, or this integral is following that scheme of form which we want to integrate. So fx equals to cot x, f dash x will be negative cosec square x. So e raised x cot x, call it as e raised x fx, and minus cosec square x. When you take f dash x, it will be negative cosec square x, so you can write it as f dash x. If you take fx as cot x, f dash x will be negative cosec square x. So I'm just showing it you side by side just to understand that how we formulate the question or solve the question with the actual result which we have proven already. So e raised x fx plus c will come. What is fx here? Cot x. So e raised x cot x plus c. Alright, this is the answer. You don't have to go forward if it's just a multiple choice question or 1 marks question. Always take, but now we need to go ahead also. Always takes e raised x into fx equals to t. What is e raised x into fx? See, fx is cot x here. So e raised x cot x equals to t, just assume like that. Differentiate both the sides. It will be e raised x, cot x will be minus cosec square x. Then plus cot x will remain like that. E raised x differentiation will be e raised x only, equals to this dt by dx. Now just rearrange these just to make look as the integral we have in our hand. So we have cot x, negative cosec square will go like this after this, and this dx will bring upstairs on the left hand side. Dt will remain like that. So integration of these two. Let's integrate now. But dt integration is t plus c. But the left hand side, what is the integration? You don't have to integrate. It's the actual question which we are solving. So just write capital I. I equals to t plus c. So this I will be equal to, what is t? It was e raised x cot x. Remember we assumed it earlier. E raised x cot x plus c. That's your final result. And we proved it also. So we gave you 2 solutions, whichever you want to follow according to the marks. And this is how you are going to write also, because I just skipped the writing because I concentrate more on the logic so that your time is also saved. Now this is e raised x minus 1 by 2x square to the first I. It doesn't seem to follow our formula, but we just give it a twist. I mean, just resolve it. You'll get that, oh, this follows our formula. So e raised x, I'm separating these two terms, x by 2x square and 1 by 2x square. So x by 2x square minus 1 by 2x square dx. What is x by 2x square here? You can cancel this, 1 by 2x will come. And 1 by 2x square will also come. That is, assume that 1 by 2x is fx. Fx is 1 by 2x. When you differentiate this, negative 1 by 2x square will come. 1 by 2 will remain like that. This x will go up and it will be negative 1 by x square. So if you assume fx as 1 by 2x, f dash x will be negative 1 by 2x square. So it has formed, or it has taken the shape of e raised x fx plus f dash x, and whose direct result we are already aware of. So you can directly write fx is 1 by 2x. I am telling you f dash x is negative 1 by 2x square. So you can just write e raised x into fx plus c. That is the answer. So what is fx? 1 by 2x. So e raised x by 2x plus constant of integration is our final result. But if it is of higher marks, not of 1 marks, then we cannot just say that, oh, this is the formula and this is the answer. No, we have to prove it. For that, e raised x into fx, whatever you presume as the function fx, because it can be the first following e raised x, it can be second following e raised x, it can be any of these two functions can be fx. So if you assume that the fx is 1 by 2x in this case, so e raised x by 2x has to be taken as some t. When you assume this has to be t and differentiate both the sides, when you differentiate, this will be, you know the product formula, so I'm applying the same thing. So I'm differentiating 1 by x right now, 1 by 2x actually, so 2 is a constant, so it doesn't affect. It will be negative 1 by x square. So negative 1 by x square plus, and 1 by 2x remain like that. Integration of e raised x will be, differentiation of e raised x will be same, e raised x equals to dt by dx. Now I'm just rearranging, taking e raised x outside. So I'm swapping these two terms, taking e raised x outside. So 1 by 2x I'm writing first and negative 1 by x square after that. But 2 remains with both the terms. Dx bringing upstairs on the left hand side, dt will remain on the right hand side. Now let's integrate both the sides. When you integrate both the sides, the right hand side will be only t plus c. The left hand side you don't have to do anything because this is the actual question we are talking about. Actually it's I. So just write I equals to t plus c. What is t? T we took as e raised x by 2x. So e raised x 2x plus c, that is the second way of solving it. Okay. So this is how you're going to go about it. I try to give you the printed version of the solution or the reference because it's very important for you to learn how to write. This we are going to take in the next discussion. Till then, thank you so much and have a good one.